welcome back. This is the third passage of SAT Practice Test 1. Like the other passages, the first step is to read the blurb, that thing before the first paragraph and the first paragraph, and then also to summarize the first paragraph in a couple words, four or five words or less. So let's read the blurb first. This passage is adapted from J.D. Watson and F.H.C. Crick, Genetical Implications of the Structure of DNA, 1953 by blah, 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 blah. Watson and Crick deduced the structure of DNA using evidence from Rosalind Franklin and R.G. Gosling's X-ray crystallography diagrams of DNA from. So right away we know that this passage is obviously science related and going to talk about DNA. Now, I'm guessing that the first paragraph is going to be DNA related as well. The chemical formula of DNA is now well established. The molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate groups. To each sugar is attached a nitrogenous base, which can be of four different types. Two of the possible bases, adenine and guanine, are purines, and the other two, thymine and cytosine, are pyrimidines. So far as is known, the sequence of bases along the chain is irregular. The monomer unit consisting of phosphate, sugar, and base is known as a nucleotide. So again, really it gets into some details regarding DNA, but to summarize, it's kind of like just the DNA, the description of DNA, some of the definition, and going into some more details about the its bases and so on. I don't think we have to get fairly detailed in our summary here. Now, the first question of passage 3 has us look at lines 3 and also around line 39, which is here. So I kind of skipped and pasted line 39 through 45, so we can read both and answer this question. The author uses the word backbone in line 3 and 39 to indicate that what? So we're going to answer this in our own words before jumping to the answer choices. So we have backbone here. The chemical formula of DNA is now well established. The molecule is a very long chain, the backbone of which consists a regular alternation. So the backbone, regular alternation of sugar and phosphate groups. So that's really important. Let's look at here. The phosphate sugar backbone of our model is completely regular. Again, we have regular alternation, completely regular, but any sequence of the pairs bases can fit into the structure. It follows that in a long molecule, very many different permutations are possible, and it therefore seems that the precise sequence of bases is the code which carries genetical information. So again, as you can see, I'm not just reading lines 3 and lines 39, I'm also reading around lines 3 and 39. So this is lines 3, but in line 4, I found regular alternation. Then after line 39, line 40, I found completely regular, different permutations. So to indicate that there is an alternation, it alternates, a regular alternation, a sequence. That's another thing. So a regular alternation, there's a sequence, a permutation. That's going to be my answer. Now we go to the answer choices and eliminate. Instead of picking the right answer, let's eliminate the ones that are least like our answer. So A, only very long chains of DNA can be taken from an organism with a spinal column. It doesn't say that at all. The main structure of a chain in a DNA molecule is composed of repeating units. repeating, we have alternating, sequence, permutation. Let's keep this one. This is close to what we said. C, a chain in a DNA molecule consists entirely of phosphate groups or sugars. It's not what we said, and it's not what it said in the text. Nitrogenous bases form the main structural unit of DNA. No, we talked about repeating, alternation, alternating, sequence, permutation. So the best answer is B. So I'll see you in the next video where we will tackle problem number 23.